hand over directly to you, Zhipeng. Oh, and do I introduce you as Huang Zhipeng or Zhipeng Huang?
Zhipeng is okay.
Okay, I'll go with Huang Zhipeng. It just sounds, because I lived in China before, it's weird to...
Oh, your pronunciation is really good.
Sophia's is probably better. She lived in China too.
Yeah.
Okay, great. Whoa, that just filled up. Nice. Okay, it's the top of the hour, 2 o'clock. We're doing things a little earlier than usual this time. It's great to see everyone here. I'm seeing a few familiar old faces, well, bits of text on screen like Giancarlo, like Sung Soo, and some new ones as well, like Diksha, Anya, Isha, Shinchan, Zbit. So yeah, fantastic to see you all here. Welcome to another in the long line of Jina's Engineering All Hands, our event where we all get together to listen to cool engineers talk about cool engineering stuff. We're happy this week to welcome Huang Zhipeng from MindSpore in China. He'll be talking about how MindSpore and Jina are doing cool things together. I'll just kick off by going over some recent things that we've been up to at Jina. So first up, thank you so much to everyone who helped with our FAQ campaign. We couldn't have done it without the community, and all of your FAQs were effing wonderful. So we will have the FAQ doc up on our learning portal in the next few days, so keep your eyes peeled. For anyone who has any questions or wants to submit a question to be answered or answer a question, check out our Slack. There's a spreadsheet there of where you can get involved. And when you do, you'll have your name forever enshrined in lights on our learning portal. Other cool stuff. So we've got several upcoming events. We don't exactly have fixed times yet, so keep an eye on Slack, but we're talking offline events in Berlin. We're talking online office hours. So if you have support queries or you want to talk about your use case or just get to know the Jina team a bit, we'll be doing one of those over Zoom in the coming weeks. So all eyes on Slack, people. And finally, from our side, we've got a whole bunch of new example Jupyter notebooks up on our blog. So if you want to learn how to use FineTuner to improve the quality of your search results using the PyTorch, Paddle, or TensorFlow frameworks, we got you covered. If you want to use Jina's new Dockeray, our new library that is a data structure for unstructured data, that's right there on the blog as well. And these are notebooks. You can play with the code, you can change it, you can run it all in your browser. Right, that's it from my side for now. I'll shut my mouth for once in my life, and I'll hand over to Huang Zhipeng. Over to you, Huang.
Thank you, Alex. And hello, everyone. I'm not sure what the time zone you guys are in. So good morning or good afternoon. Guten Tag. It's a really honor to be invited by Jina team to do the EAH today. And I was going to do some demo. I was supposed to do some demo today, but I underestimate the Spring Festival and all the shenanigans I have to deal with. So I will talk through a slide set, which I normally, which is my occupies most of my time. Hopefully show you guys some of the work in progress. I play a bit with Jina and MindSpore and the fine-tuner stuff, which really impresses me. So yeah, hopefully you guys can enjoy the talk. So without further ado, let me just get started. Okay, can you see the slide?
Loud and clear.
Okay. So first of all, for those of you guys that didn't know me before, I'm currently the director for Send open source ecosystem at Huawei. I'm the TAC, which stands for Technical Advisory, I think, Committee for LFAI and Confidential Computing Consortium in Linux Foundation. I previously worked mostly at cloud computing side of things. So I was the co-creator of the policy working group in Kubernetes. If you are still involved in Kubernetes development, you probably someday will run into this working group. And also co-found the security SIG, which probably the first SIG in CNCF. And earlier than that, I was in OpenStack. I created a project called SciWork. Has a cool name. It's basically a general management framework for all kinds of accelerators, which are predominant and now for AI applications. But when we were doing SciWork project, it's mostly for telco applications, for network function virtualization, that kind of thing. So we have a team in Huawei works on all those kinds of open source project. Also includes like Onyx, Kubeflow, Akrino for edge computing. I'm a big fan of heavy metal. If any of you also shares this enthusiasm, feel free to ping me. I'm on Twitter. Okay. So I'm gonna talk about MindSpore. What is MindSpore and our community? Our team essentially is responsible for building what is TinyMS and what MindSpore, Julia, and Jina could do together for a very interesting future. So MindSpore is essentially a new deep learning framework developed by Huawei and open source on March 28th, 2020. So it's barely 2 years old. So as you can see, this is the offering from the Ascend product line. So we have offerings for like application development. We have offering for sort of like CUDA, the counterpart of CUDA, we call CAN, and the frameworks. So for Ascend platform, we support TensorFlow, PyTorch, all those mainstream deep learning frameworks, but it works better and achieve amazing performance with MindSpore. This is just I think I use a old figure, but just give you a sense of how powerful MindSpore running on a Ascend hardware platform is. I still remember when we first open sourced MindSpore, one of the developers took the liberty to run a test on Huawei's cloud himself. Found out that he easily beat the TensorFlow on V100 and also PyTorch by like 1.8 times to 2 times. So a deep learning framework optimized for a ASIC hardware is really powerful. Okay, since this is like engineering hands-on workshop, let's go to the details. What is MindSpore? So from the Jina's code base, I believe you guys are pretty familiar with all kinds of frameworks. So MindSpore is not just yet another one. I know there's a trend, like a lot of companies are creating, well, reinventing the wheel, so to speak. However, MindSpore is sort of a implementation of a vision we have for the future evolve of AI frameworks. So for MindSpore, other than we provide really like easy to use interfaces, we bring a lot of hardcore feature with it. For example, MindSpore has a really big emphasis on compilation optimization. So one of the key features we call the automatic parallelism. If you have ever tried like run a distributed cluster to train a really like huge model, you know that parallelism is vital, and for engineers that are like a data scientist to begin with is sort of a big burden for them. So MindSpore introduced this really cool automatic parallelism mechanism that the AI scientists only need to specify a few key parameters, and then the framework will figure out the best parallel policy for it. So I will just go through a couple of key features. So the first one I mentioned. So basically, MindSpore, we have a policy space, and we try to do a search and find the optimum policy given a set of parameters which like used to be handcrafted by engineers, like how many hardware, like some cards you have or GPUs you have, what are the communication protocols, what are the memories, you know, how you best to shard the data set or shard the model. So it used to be a lot of handcrafting, but with MindSpore, you just need just one line of code to indicate how many cars you have, and framework will take care of the rest. So this is really cool, and it enabled our team to develop the first, I think, 100 billion parameter big model in like sort of the Chinese version of GPT-3 earlier last year. So the second one is second order optimization, or we are working on like high order optimization. So second order optimization is not a new thing. A lot of framework have already tried to do that, but there are a lot of obstacles you need to get over. Like for example, for second order computations, you will encounter a lot of the matrix computation, and you need to figure out a way of efficiently compute a lot of the Hessian matrix, and in the meantime, you don't have like the loss of the gradient, all those things. So MindSpore is kind of first thing is kind to achieve a positive gain for second order training. And well, the dynamic graph and static graph, I think all of the frameworks are support like both mode now. But with MindSpore, and if you are using a SAN hardware, it's just one line of code to declare the mode in the context. and then you're set. You don't need to do anything else. Okay, since we have hardware offerings like spanning from cell phones and to cloud, MindSpore is designed from start to support what we call all scenario. So that means we have a really strong intermediate representation called MindIR that could adapt to different scenarios, and then we adopt different compilation strategy so that for scenarios that need really small models, you can basically have a really lightweight MindSpore Lite model, and for the cloud, you have the traditional heavyweight size model. And well, this is sort of a giving. If you have a really great ASIC hardware offering, your framework could be optimized really good. We bring a lot of toolings too for like profiling, and from hardware level to the framework ops, and also MindInsight, similar to TensorBoard, Web UI. So one of the things that set MindSpore apart is our emphasis on empowering the AI and AI for scientific computing. So what we believe the future directions of AI will be heavily focused on how to empowering scientific computing. So there are some well-known limits for the traditional numeric method. So if you're doing really high dimensional differential equations, will have a huge number of computations, and the boundary conditions are very complex. You are basically impossible to navigate. But with AI, the black box model basically provides a nonlinear fitting. Although you don't know why you can do that, but you can just solve a high dimensional equations. So the last one is Trust AI. I think especially for Europe, this is like a key area. More and more companies are focusing on now. So for AI security, it involves like how do you protect the model from attacks? How do you protect the model and the data set during training and inference process? And the more difficult one is provide OS level security protections. We call the enclaves. So if you are familiar with confidential computing or something like that, so it's basically means you'll be running your training task in a TEE, which is not very performant for sure, but it provides really great security. Okay, so some great use cases. So earlier last year, we released the first ever Chinese version of GPT-3. It's a monster model, and it's a huge breakthrough. So we I think we saw a flourish of big models after the release of PCIL. Another like really interesting use case for us, and this is for AI powering scientific computing, is for weather nowcasting. Nowcasting means So for city like Shenzhen, forecasting is not enough. Most of the area that needs forecasting are looking for really short range predictions. So they call the nowcasting. So it's a nowcast. So the Weather Bureau in Shenzhen actually utilized the LLM written in MindSpore to do that. It has a pretty awesome result now. This is one of the oldest and one of the use cases that we are really proud of. So we are collaborating with the Shenzhen Bay Laboratory to develop basically the deep learning solutions for molecular dynamics. So as you know, for example, if you are in a big pharmaceutical company, you want to develop like new medicines or have like new vaccines for Omicron. I don't know how to spell that correctly. One of the key technologies using the molecular dynamics, basically to predict how the protein will be like folding or forming in a way. So traditionally, this is like requires really high dimensional, like 4 to 5 order differentiation to do in the traditional numerical computing. But with the help of deep learning model, it really cut the time in just a couple hours, and with MindSpore had a great support for like auto differentiation. The scientists now can do like higher order differentiations with affordable time range. Okay, so other than those awesome use cases, as a big company as Huawei is, we also use it like internally, and I think the most stunning figure is the invocations on the cell phone. So as you know, every Huawei phone has shipped with MindSpore Lite in it. So if you ever use AI-related application on the Huawei phone, you are basically use what MindSpore Lite offers. So we have like 700 million calls, I think, per day. So this is really an astonishing figure. Okay, now we go to some light-hearted section of how our team are building a MindSpore community. So I think in a relatively really short time, we've built the hottest AI open source community in China. It's not only by the numbers. For example, we achieve more than 1 million downloads in just a year's time. And so one of the things we do for community is that we actually develop solutions that are driven by community. There are 2 examples. We collaborate with one of the like nature protection center in China. We help them develop the first ever there's a pre-trained model for the Sanjiangyuan, which is the upstream of the Yangtze River, using the ultra-red camcorder. The other one is we use the MindSpore CycleGAN model for the tie dyeing craft. I don't know how to say that in English, but it's a really cool, and I think it's a UN non-material heritage. So it's just a really long historic process of dyeing dyeing a wool or sort of clothing. So we used Cyclegan to help one of the AI artists to generate a lot of the new patterns for the tie-dyeing craft. So like I said, it's not just numbers. We innovate in a way that very few open source community like tried before. For example, we actually held probably the only like AI centric roast in China last year. It was just it was hilarious. We are looking for the second roast this year. We have we have like a hack week for every half a year. We organize women in tech events in China, and we held like specific topic workshops for like molecular modeling. Okay, and also if you go to our official website, we set up like campaign trails for how do you make contribution in open source in MindSpore community, and we also have a really like a gaming certification system for our developers, so you can like read up the letters. Okay, so we have began like our overseas outreach officially at the end of last year. So you are more than welcome to like subscribe to our Twitter, YouTube, and Reddit, and yeah, check us out. So okay, quickly go to the next section called TinyMS. So what is TinyMS? For those of you who are familiar with Keras or FastAI, TinyMS is open source by my team, so it's a high-level API toolkit basically for MindSpore. We especially target our users for those entry-level students, or we have developers that from companies that are not AI-centric but only want to use AI capabilities. So for those folks, even for a new framework like MindSpore, which is really easy to use in comparison with older frameworks, is still pretty difficult for them. So that's why we developed TinyMS to provide just a set of really high-level APIs for those entry-level learners to quickly have a on-ramp experience with MindSpore. So in concept, it's pretty similar to, I think it's more similar to FastAI than Keras. So we basically abstract away a lot of details from MindSpore, so that you can like write your own .NET just in 1 minute. It's possible. Okay, I will just quickly go over the several modules. We have the data pre-processing. Model construction is pretty easy, and more easier like training. This is all done with the support of MindSpore as a underlying framework, and this is the evaluation metrics. And sorry, so we have a grid serving module. Okay. Topic of today. So Julia, I think most of you guys are familiar with Julia, so I won't. Well, I'm not an expert. So Julia is well, it's not a new programming language, but is a trending programming language for AI in recent years. So Julia has been traditionally used for numeric computing and scientific computing, but recently there has been a lot of development for machine learning and deep learning support in Julia. So there are like two projects that are representative. So one is MLJ. Well, MLJ is not like one project. It's a like set of packages, and the other one is FluxML, which is now I think the default deep learning and machine learning Julia package we go to. So for if you are not familiar, there's I don't think I need to show the recording here. Oh, Jesus. Okay, so it's really simple. It's a MLG example. If you install Julia and in the command line interface, you can just do a quick like tutorial for MLG. But for FluxML, I've tried with FluxML. I think it has great support, and it's very promising to use. So we have been like discussing how MindSpore and Julia could work together, and there are two possible ways that came up. So there has been a lot of discussion like Julia versus PyTorch, and so for MindSpore, its key advantage is its compilation optimization, as I just introduced. So from the Julia, the China Julia community feedback, so we believe probably the best way is to just utilize MindSpore's capability for cogen for Julia. So essentially, we'll develop a Julia compiler plugin. So Julia will be sort of like a Pyro or Jusuan or that kind of front-end library, FluxML basically. So MindSpore will do the cogen, especially for large-scale clusters. I think this is really beneficial for Julia, and Julia could bring a lot of the scientific computing and especially ODE capabilities to MindSpore. So this is a really great way of integration. The second one is through TinyMS. So we thought about like Julia doesn't have this kind of high level API sort of things. So this might be the second direction we'll be looking at. So to basically give FluxML a high level API, although FluxML is really easy to use as it now. So okay, Julia and Jina and MindSpore. So this is really not like a real combination of the three, but okay, let me reshare the screen. So I'll be just share with you guys the failure I have been. Well, I'm not a great developer, so anyways. Okay, so last year, the first MindSpore integration, there's a blog post read up from Dr. Xiaohan. So last year we did a quick demo with Jina in its early version and also MindSpore in its really early version. So this is the earlier example of how the fashion MNIST data set, and you do the fashion demo with Jina. So unfortunately, I found out that the Jina itself has the interfaces has evolved a lot, and there's a just annoying bug in MindSpore. Still hasn't been fixed, I think. So there's a annoying PyTest error that it just wastes, I think, half of my day. I just pretty so just give it up. Okay, and so for Jina, I did a local build. I built the Jina source code locally. I'm a huge fan of bare metal, so I like to build source codes. I think there's just one error. There's a so I need to like just replace with a fixed declaration of the class names for the compilation to get through. Otherwise, the compilation and installation is pretty smooth. So I was looking at this. Maybe I can hack the fashion demo here. But then I just going over Jina's official website and find the fine tuner, which is really cool, I think. So for fine tuner, I think from model to embedding and from embedding to model, this will be a very useful tool. So the experiment kind of half-assed at the moment is I want to like just add one a new framework support for TinyMS. Why use TinyMS is that I think I tried with a high-level API Keras, but should be easier. So many of the high-level semantics are similar between TinyMS and Keras, but I think that it's just the devils are in the details. For example, for TinyMS, since we did a really high-level abstraction, we kind of it's really difficult to just do a simple 3-layer MLP like the other frameworks. I have to find a way to have our high-level APIs to come with a way to form a layer list. Luckily, we still got several APIs I can use. So I think after I finish this one, I should have a working prototype without any tests, of course. So I think another interesting detail is like MindSpore is really in a way similar to PyTorch, and when you develop a high-level API toolkit for that kind of framework, TinyMS has things that's similar to Keras and things that are really similar to PyTorch. So this is another stuff I need to navigate through my experiment. So I copy over the Keras code and start modify it, and well, it's not a trivial task as I envisioned, but it should be. I think I can get it done this week. After all the PowerPoint work I have to do in the company. Okay, so this is like the failed demo I've been trying to show you guys. And back to the topic, what's the future for like these three amazing open source project can do together? I think it opens up a great possibility. So Jina for MindSpore and Julia, Jina is a great front-end sort of engine for the neural search. So the integration of MindSpore and Julia basically brings up the possibility of a running like large cluster with the support of well, Julia compiles really fast, so you will have a really performant framework front end for your model, and with integration of Jina, I think probably we'll have a really performant large scale neural search engine that I don't think any other frameworks can do this stuff. So this is the future that fascinates me the most, to be honest. And the other one is fine-tuner. Fine-tuner is really cool stuff. I think to utilize fine-tuner for the fine-tuning of MindSpore and Julia's integration, possibly a MindSpore-backed FlexML model, that would be just mind-blowing, I think, to see how you convert the model to embedding and back and forth. Okay. So I hope I did give you guys a good enough talk. So please follow us on various sites, and thank you for your time. I think we can go to Q&A.
Perfect. Thank you so much. Okay, so we've already got one question from Giancarlo. Great to see the support for second order optimization. Can you expand on the ResNet training example?
Okay, let me. So I think, as you can see, so for second order optimization, we first tried with ResNet, and so in theory, if you have a good enough second order optimization mechanism in hand, you should cut like the training in half, basically. However, like I mentioned, a lot of frameworks can even converge when doing the second order optimization. So for ResNet, I think we, I think this is we run on a 8-car Ascend 910 device. So it took about 70 minutes to converge compared to first order accuracy by SGD. This is pretty amazing. We did BERT after ResNet, but I think this slide is outdated. but I think in general, the performance gain is comparable with ResNet. So I asked the team, so the architecture of the model should not like bother that much. The optimizations that we used for ResNet models is also applicable to BERT. So that means second order organization is could be well generalized for vision tasks and also for NLP tasks. Yeah.
All right, perfect. Thank you. And if you have follow-up questions, people, just post them in the Q&A. Because Giancarlo, I think you and I were thinking of the same question. So if you post that, that'd be cool. A question from Sung-Soo Park. Is knowledge of Python and Julia enough to start participating in the MindSpore community?
Oh, Python is enough. Julia is something we want to experiment this year. So if you know Python, you can play with MindSpore now. Oh, I think I should mention this. So starting from 1.6, MindSpore support like Mac OS. So as you can see, you can just compile MindSpore or pip install, or if you like me, just compile the source code on your MacBook and start just Python programming. Yeah, it's very easy.
All right, thank you. Perfect. I think Giancarlo is writing his question now. So who's your favorite metal band?
Oh.
That's not his question. I'm just I
know. So well, for metalheads, I think the big four, I love them very much. So Metallica, I think, is my favorite band for the older generation of bands. So for younger generations, I think Trivium. Trivium is great, and from Germany, like Rammstein. Another. I'll just sleep through my mind. So there's another, I think, what do you call it, deathcore band? Or, oh, Heaven Shall Burn. Heaven Shall Burn is a great band from Germany. Well, yeah. So Wacken Festival is like something I keep watching on YouTube and never got the chance to go to myself, which is a bummer. Yeah, that shows the level of my interest in heavy metal.
Can you tell us a bit more about the protein stuff that was
sure.
in the deck? Because Giancarlo actually created an example for protein search using Jina. So we're all really interested in
that. Okay, let me go to the. So I happened to recently just give a talk on the AI scientific in China. So we use MindSpore to implement FFO2 as well. I think it's the first non-JAX framework actually implemented FFO2's paper, and we open sourced the code as well. Okay, let me find the molecular dynamics. I think, yeah, it's this one. Yeah, so so from what the professors told me, as much as I can I can understand. So the difficulty lies in that they need to like have I think have a history, like a timeline, how the items, the positions items are related to each other. They need to have a timeline or a history prediction of how those positions gonna evolve. That's the essential problem for molecular modeling. That if we want to model that, it's easily like 4 or 5 order differentiations you need to do, because you need to take into consideration of the relative positions, the time, and there are a couple other elements I can remember. So what like impresses them from AI is that, for example, like the GAN model, you can just approximate the equations using a deep learning model. So what they developed is for molecular dynamics. There are 2 ways of deep learning. One way, I think they call it the descriptor-based mechanism. The other one is basically graph GNN based. So I think the team collaborated with us, went with the GNN based approach. So well, MindSpore is just a framework, a tool. So the algorithm, the model they developed called AirNet, I think it's a graphic representation of certain protein, like how molecules and how the atoms relate to each other, represented in a graph, and yeah, and do the training on the graph. And they didn't build the model from scratch. I think they built on backbone of BERT. So another major obstacle they have to overcome is the data labeling. The cost of data labeling for a molecular modeling is really huge. They mentioned I think they label just one protein for a month, and it just costs like billions of RMB like that. So they don't have the luxury to train the model from scratch. So I think they picked the backbone of BERT, and yeah, basically integrate a GNN-esque some layers on top of it to build this new model. It's called AirNet. Yeah, I think I've talked enough as an amateur.
I think that mostly answers Giancarlo's question, but he gave some follow-up stuff as well.
Okay.
So he's saying we explored protein structure neural search with Jina by adapting NLP techniques to amino acid sequences. It would be great to see if there are any common interests there.
Oh yeah, yeah. Oh, definitely. So I think this is one of the key areas we will be our core development team will be focusing on for sure. Yeah, I think Jina could do great. I've been like combing through the Jina's code base these days. It just amazes me how you guys like abstract way the interfaces is really nicely done. Yeah, for the neural search with Jina on the amino acid sequences and protein like prediction, absolutely. like I mentioned, the AlphaFold 2 implementation is already open source. I can just send if there's any of you guys are interested, I can send you the link. I think it should be on GitHub as well. So we have a sync mechanism from the Chinese counterpart of GitHub to GitHub. So I think it should be on GitHub now. So you guys could check it out, the MindSpore source code for the AlphaFold 2 implementation, and then I think we can do great collaboration. Yeah.
Fantastic. Jeans and Gina do go well together.
Oh, I need Jean. Jesus. There's intro level article on. Oh yeah. Yeah, the code. Yeah, the code is out of date. I just tested. Yeah.
All right. I think those are all of our questions. Oh, one more thing from Giancarlo.
Okay.
I understood that MindSpore. Sorry.
Encore.
Encore. The encore of the encore. I understood that MindSpore is the compiler backend for ML models. Is that correct? I thought Julia excelled, especially in its own compiler capabilities.
Oh.
What's the advantages of MindSpore in this respect?
Oh, it's I think it's both correct and incorrect. So MindSpore has its own front end. So for compiler, what you have to keep in mind, well, for a compiler amateur like me to understand, is that there's always a front end and back end. So for compiler optimization, you always look at these two sides. So front end, there's a front end, and there's a back end. So for front end, is mostly deals with how to translate your source code to the IR, and for the backend, is mainly deals with what we call the codegen. So to generate a really low level code from your IR. So I think both Julia and MindSpore have front end and back end. The integration plan I mentioned actually came from the Julia folks. Is that Julia, as well as PyTorch, is not really good at the backend optimization, the codegen optimization, because for codegen you need to deals like with a lot of the hardware facing LLVM level optimizations. So for Julia, the best way to integrate a framework like MindSpore is to basically switch off the MindSpore front end with Julia. In this way, we achieve, like, we have both of our advantages. So Julia compiles really fast for a front end, and MindSpore compiles really great, especially for large distributed cluster. So yeah, that way to combine the strength of both projects. A miserable way could be like MindSpore's front end with Julia's backend. Well, that's another topic. Yeah. So anyway, that's the reason why the integration planning looks that way.
Okay, and yet another question, not from Giancarlo. So this one's from David, who's one of our team of engineers here at Jina. Would this mean MindSpore would be like LLVM for Julia? So the front end of MindSpore would be the typed AST from Julia?
I think in a sense, yes. So if we switch to like the context of MLIR, it will be so MindSpore will became a dialect of MLIR, and then Julia will use the MindSpore the dialect as the codegen. It's sort of like that, since since like Julia and MindSpore all have, like I mentioned, we all have end-to-end capabilities. So it's not very strict positioning. But I think you can put it that way, like Julia as like you said, the typed AST from Julia, so as the front end of MindSpore, but MindSpore does not sit that low level as LLVM, since our codegen actually need to utilize LLVM as well. So it's like sort of like in the middle, I think. Yeah.
Great, thank you. All right, I don't see any more questions now. If any of you have questions, speak now or forever hold your peace.
Or follow our social account to ask questions there.
Exactly, just tweet at Japan.
Yeah.
Great, so thank you so much. We've covered so much. We've covered genes and Jina, bare metal, heavy metal, all the metals.
Yeah.
So yeah, it's been great having you here, Japan.
Oh, thank you. Yeah, it's great to be here.
All right. And yeah, thank you so much to our community for joining us as well. I've seen a lot of people here, like really good to see all the old faces and newcomers too. So yeah, just to wrap up, if you want to find out more about MindSpore, you can go to, what's the place?
Just GitHub MindSpore -AI, like Jina. And our website is mindspore.cn. And there's an English version right on the right upside corner. You can switch.
Perfect.
And just check him out on Twitter. If you have any questions, feel free to DM me.
All right. And as I said at the start, we've got a lot of events in the Jina calendar coming up. Not everything's confirmed yet, so keep an eye on our Slack. And yeah, thanks once again, and we'll see you all next time. Bye-bye from Jina AI.
Auf Wiedersehen.